we're going to take a look at sampling distributions. Now, first of all, the definition is that a sampling distribution of a statistic is a distribution of all values of the statistic when all possible samples of size n are taken from the sample proportion. So there's a lot of things going on here. It's probably just easier to look at this through an example. So we're just going to focus on a sample proportion right now. So for this one, we're talking about the distribution of all sample proportions of size n taken from the sample population. So the sampling distribution will tend to be approximately normal, and then the sample proportions target the value of the population proportion, which means if we were to take the mean of all the sample proportions, it would equal the population proportion. Now you have to be very careful here and pay very close attention to notation here. Notice we have p hat representing our sample proportion, and then just the, it'll usually be an italicized p in your textbooks, is representing the population proportion. So make sure you keep those separate from each other. So let's look at what this all means through the use of an example here. So when 3 births are randomly selected, the possible outcomes for gender are, we could have girl, 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 boy, etc., etc., etc. So these are all possible outcomes when we are selecting 3 births at random. So we are going to assume that these 8 outcomes are equally likely. So we're assuming that the chance of a boy is equal to the chance of a girl. What we're going to do is we're going to construct a sampling distribution for the sample proportion of girls from 3 births, then compute the mean of the sample proportions and compute the population proportion. All right, so if we look at this terminology here, construct a sampling distribution. That is essentially just a fancy way of saying make a table. And we are going to be looking at the proportion of girls. Proportion, okay, keep that in mind, proportion of girls from the 3 births. So if we look at our first one here, the proportion of girls, well, this first one we had 3 girls out of all 3 options. So my proportion was 3 out of 3, or 1. When I go to my second one, we had 2 girls out of the 3, so my proportion was 2/3. And I need to do that for each of these. Okay, now when I get to this one, I only had 1 girl out of the 3. And then for my last one, I only had 0 girls out of the 3. So these right here represent my p-hat values. They are my sample proportions. So when I come over here to make my distribution, I usually put my values in from smallest to largest. So the smallest sample proportion that I could get would be 0, the 0 out of 3. Then my next smallest value was 1/3. My next value was 2/3, and my largest value was a proportion 1, so all of them were girls. Now to finish out my sampling distribution, I figure out what's the probability of each of these things happening. Well, 0 only occurred this one time, so it occurred 1 out of the 8 times there. So my probability for this particular sample proportion was 1 out of 8. Then I go to my 1/3. Well, my 1/3 sample proportion occurred 3 times, so it occurred 3 out of the 8 times. So the 8 comes from there's 8 possible outcomes here. The 2/3. Okay, there were 3 ways that we got 2/3 out of our 8 outcomes, and the sample proportion of 1 was 1 out of 8. So the next thing it wants me to do is it wants me to compute the mean of the sample proportions. So I'm going to use my distribution there to compute my mean. Now in order to compute my mean, I need to take the proportion times its probability in each of these cases and then add them together. So I would have 0 times 1/8 plus 1/3 times 3/8. That would be my second group here. Take my third group plus 2/3 times 3/8. And my last group is 1 times 1/8. Okay, so when I do that computation, I'm going to do it all together at once. I end up getting 0.5. So that is the mean of my sample proportion. And the last thing it says compute the population proportion. So when I come back up here to my original data set, I need to count how many girls were there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There were 12 girls. And the total number of births that we have listed here would be 24. So 12 out of 24 would give me 0.5. So notice how my values turned out to be the exact same. So that's what was meant on that previous slide where it says that they target the population proportion. When we find the mean of these values, it's the same as our proportion for the actual population. Okay, so now our process when we look at the sampling distribution for a sample mean is going to be the same type of thing. So we're looking at the distribution of all samples of a particular size taken from a population. Now, when we have the sampling distribution for a mean, again, this distribution tends to be approximately normal, and this will become closer to normal as we increase our sample size. And then our sample means, again, target the value of our population mean. Now, do not assume that that is the case for any type of measurement we want to find, because it is not. Okay, it is for proportions and for means, but not for everything. So when we look at this one for an example, so let's say the commute to work for 4 people are 20 miles, 12, 16, and 14 miles. Assume we're going to take a sample size of n equals 2, and we're going to randomly select them with replacement from this population of 4 people. So we are asked to construct the sampling distribution of the sample means, compute the mean of the sample means, and then compare that to the population mean. All right, so the first thing that we will need to do is we are going to need to list our samples. Now, in our previous examples, our samples were already listed for us with the boys and girls. In this one, we have to list them ourselves. So now notice we are going to take a sample of size 2 with replacement. So I'm just going to start working with the value of 20 because it's my first one listed. So I could have 20 paired with 20. I could have 20 paired with 12. I could have 20 paired with 16. And I could have 20 paired with 14. So I just went 20 with 20, 20 with 12, 20 with 16, 20 with 14. Now I'm going to go with my, my 12s. So I could do 12 with 12, and I could have 12 paired with 16, and I could have 12 paired with 14. Now the reason I don't have to do 12 paired with 20 is because I already had that one listed up here when I did my 20. So now I'm going to do my 16, so I could have 16 and 16. I could have 16 and 14. Okay, and then my last one would be 14 and 14, because I've already paired 14 up with everything else. So that's going to be our sample space. Now what we need to do is we need to find the mean of each of these pairs, because that's what we're trying to do here. We're trying to find the distribution for a sample with size n equals 2 for the mean. Okay, so when I compute the means of each of these, I'm going to have 20. And then the mean of 20 and 12 is 16. The mean of 20 and 16 is 18. 20 and 14 is 17. 12. Let's see, 12 and 16 would be 14. All right, so now that I have my means for each of my samples listed here, I can compute my sampling distribution for these. So I'm going to go ahead and set my table up here. Okay, I'm going to label my first column here X bar because it's my sample means. And then my next column is going to be the probability because I need to find the probability of each of those happening. So now as I look over here at my list of means, it looks like my smallest is 12. And I go clear up to my highest of 20. So I'm going to list these values in here, clear up to 20. And now I'm going to go back and find the probability of each one occurring. So my 12, it looks like my 12 only occurs one time. And I have 10 different samples here. So my probability would be 1 out of 10. My 13 also occurs only one time. So my probability would be 1 out of 10. Let's see, 14 occurs 2 times. 1, 2. So I would have 2 out of 10, which is 1 out of 5. And I'm going to keep doing that with each of these. So there I would have a sample distribution of my sample means. I have each of my values of my sample means. So this is the mean of each of these samples. And then I have the probability of it occurring. Next it says compute the mean of the sample means. Well, to find my mean, I would take 12 times the 1/10 plus 13 times the 1/10. And I would do that all the way through. When I do that full computation, I end up getting 15.5. And so that is the mean of the sample means. Now, my population mean, if I were to just come back up to my population and find the mean of my values, I would do 20 plus 12 plus 16 plus 14, divide that by 4, and I end up getting the exact same value, 15.5. So the mean commute to work for these particular 4 people is 15.5. And again, this is just an example of how our sample mean will target our population mean. Okay, so if we wanted to do the sample distribution of a sample variance, so it's the same concept again. We're going to do the distribution of the sample variances of size n taken from a population. So the sampling distribution for sample variances, this tends to be right skewed. And then the sample variances do target the value of the population variance. So I'm not going to do a full example for this because the process is the exact same. You would list your sample space and then do your computation. In this case, you would do it for the variances, and then you would be able to find the mean of those values and compare that to the population variance. Okay, so this whole concept of sampling distributions is pretty abstract, so I would recommend going and doing some simulations. That way it will help you see and visualize how these pieces all fit together.